Today we are going to continue on with our properties of exponents, and we are going to be going from what we were doing yesterday with adding and subtracting to we now want to look at what happens when we are multiplying with polynomials. So this is actually something you have also been doing for a long time. You just never knew you were doing this. So if we're talking about the distributive property is actually dealing with multiplying polynomials. So if we have something like 3 times x minus 8, right, we have a monomial sitting out here, and we are passing it out to each piece inside the parentheses, which is a binomial because it has two terms. And so we take 3 times x, which gives us 3x, and we take 3 times negative 8, which gives us a negative 24. Now remember, right, this sign stays with that number, and it's just going with it. So 3 times 8 is a negative 24, and that determines the sign in the middle. So we're going to do that same thing today. It's just that they might get a little bit more complex, which means we might have more terms or we might have more variables. Since we are doing this in a video and we are not doing this in person, we are actually going to skip this small portion of your notes that talks about using algebra tiles because we just can't do that if you don't have the manipulatives available to you. So we are going to jump down to example number 5. And when we are looking at example number 5, we have 2x times x squared plus 5. So again, we see this distributive property happening. We're taking the 2x that we have out in front, and we want to multiply it out to each piece sitting inside the parentheses, which means we want to take 2x times x squared. Sorry guys, my table moves here a lot at home, so it's kind of shaking in places. I apologize for that. Right? And we want to take 2x times the 5. Now, we don't have to write this out each time. That's just what's actually happening in this situation. Okay, we're multiplying both of those pieces as two separate parts. Okay, so we're going to take 2x times x squared. We know when we multiply with exponents, we really want to add them. So we're taking 2x times x squared, which will give us a 2x to the third. And we'll take 2x times 5, which will give us a positive 10x. So our final answer will be 2x to the third plus 10x. If we look at number 6, we want to distribute a 7y. So we are going to take that 7y and we are going to pass it out to each piece inside the parentheses. So if we take 7y times a 4y to the third, this time I'm not going to write it separately, right? We're just going to think about multiplying these two pieces. We know when we multiply the coefficients in front. So 7 times 4 gives us a 28. And then we add the exponents. So y to the first times y to the third gives us a y to the fourth. After that, we then move to the next term. So we're going to take this 7y and we're going to pass it out to the 3. So 7 times negative 3 gives us a negative 21. Now this doesn't have another variable to go with, but just like over here, that's okay. It just comes along. Can't lose any of the parts. All those pieces need to be included as we go through. Okay, so let's take a look at number 7. This time we have a monomial times a trinomial because we're multiplying it times 3 pieces. But that process does not change. We are still just going to take the monomial, the number sitting out in front, and we are going to distribute it to each piece inside the parentheses. So we're taking this 4a and we're passing it out to all 3 terms. Okay, so if I pass this out here, 4a times a squared is just going to give us a 4a to the third. Right? I'm adding those exponents. Then we go to the next one. So now we have 4 times 14. So if you need a calculator to do that, that's fine. But we're just taking 4 times 14 and getting a positive 56 because it's a positive 14. Again, we are adding the exponents. So we have an a to the first power times an a to the first power. So that will give us an a squared. And then 4 times negative 2 gives us a negative 8. And that a is just coming along. Now you might be curious, can I combine any of these like terms? Well, look, these all have different exponents, so we can't go any further with that because we can only add or subtract if the exponents match, and they do not right now. Okay, so let's take a look at example 8. So same idea, now we just have a monomial times something with 4 terms, right? A polynomial with 4 terms. But the process is exactly the same. We're going to take our monomial sitting out in front, and we're going to multiply it to each piece on the inside. So 16m to the 5th times m squared, right? We're keeping that coefficient. We are adding the exponents. You can think about there really being a 1 there. 1 times 16 is just 16. Then we'll take m squared times negative 10m to the 3rd. So that'll give us a negative 10m to the 5th. It's kind of a tongue twister. M squared times 3m, again, we will add those exponents, will give us a 3m to the 3rd. And negative 9 times m squared will give us a minus 9m squared, right? We can't lose that variable. It still gets multiplied there, so it still counts as part of the answer. You know what, class? I said 5 here, but on this one right here, it should be a 7. So if you're sitting there going, uh-oh, Mrs. McKinney, why did you write a 5? You're right. Right, we add that 2 plus that 5, that gives us a 7. Now, it doesn't always have to be the case that it happens with one variable. So we can look at this process with multiplying, okay, and there can be more than one variable involved in the multiplication. We're still going to use the process exactly the same, so the rules don't change. We just have to remember we can only add exponents on variables that have the same base. Okay, so when we're looking at it, it has to have the exact same letter or we can't add them up. So if we go to distribute on this first one, right, we're going to be multiplying xy times 3x. And when we go to multiply here, we are just looking for parts that can actually be added up in exponents if they have the same base. So this is an x and this is an x, right? So those can get added. So here's a 1 and here's a 1. That can become a 3x squared. That y doesn't go away. It just can't be combined with it with the exponents. It just gets tacked on. Remember, all of these truly have multiplication sitting in between them. And so do these down here. So that's still multiplication. It's just not getting added with the exponents. Okay, then we'll go to the second piece. So now we'll take a negative 5y times an xy. So that'll give us a minus 5. I'm going to put the x next just because it's alphabetical order. And then I'm going to do the same thing with my y's. I can add those up, and that will give me a y squared. Okay, so when I move on to my next one, I'm going to be distributing out a 10n. So if I want to distribute 10n, I'm taking 10n times 3n squared. Those are straightforward, both n's, so those are fine. 10 times 3 is 30. 2 and 1 gives me an n to the 3rd. I can still distribute to this next one. I just might not be able to add all the exponents, right? Because now that y comes into play. 10 times 17 is negative 170. It does not matter that that y is attached to it. Those coefficients can still go together. I have an n and another n, so that's going to give me an n squared. And that y to the 3rd just is still there. It just still comes along. It cannot disappear. If we look at number 11, so while these might take us more time to do, they do not get any more difficult. The rule stays the same. We can only add exponents if they have a matching base. So the best thing to do is just sort of make sure you're only focusing on what you need to focus on. So for this first step, right, we can cover up and ignore this second term because we're just distributing here. And just think about it like the multiplication problems we've already done that are even more challenging than this. Right, negative 13 times 2 will give us a negative 26. Okay, then we have a c here, and those can be together, so we add. That gives us a c to the 6th. And a d to the 3rd with another d will give us a d to the 4th. Then we will distribute to the next piece. Again, it does not matter that it doesn't have all of the same variables. We can still multiply them. We can just only add up the exponents on the pieces with the common bases. So we can still take that negative 13 times negative 5 and get a positive 65. C squared can go with the C, and that will give us a C to the third. And that D to the third just can't get left behind. It's still part of that answer. These cannot be added or subtracted, right? These exponents aren't the same, so since they're not matching, we cannot combine those like terms. If we look at our next problem, we are going to be distributing a 9x to the third m. Now, you might get thrown off and see these negatives in here, but I always tell my students, try and distribute this out first, get rid of these parentheses, and then worry and see if you still have negatives left after that. Okay, so if we multiply our first two, 9 times 3 gives us a 27. Okay, so we have an x to the third times an x to the negative 2, and when we add that, that just gives us an x to the first. So that takes care of the negative for us, right? And then our m's, 1 plus 1 is 2. Then we can distribute to our next piece. Well, 9 times, there's a 1 there, so that's just a 9. X to the third times x will give us an x to the fourth. And if we add up our exponents on our m's, 1 plus negative 1 gives us a 0. And anything to the 0 power is just 1. So those actually cancel out, and we have nothing else to write down. Okay, we don't actually want to write down that m to the 0th power because that wouldn't be in its simplest form. We could still take and evaluate m to the 0th power, and so we wouldn't be done yet. Okay, if we look at number 13, we are going to distribute a 5ab squared, and now we are distributing it to 3 terms, a trinomial, but that's okay. We're just going to go one chunk at a time. So we're taking this 5ab squared times 3a squared. So 3 times 5 will give us a 15. And then again, we will start adding exponents. So 1 plus a 2 will give us a 3. There's no b, so that b just comes along. Then we'll go to our next piece. 5 times 5 is 25. A times a, right, we can add those exponents. So 1 plus 1 is 2. 2 plus 1 is 3, right? At this point, we should recognize if we do not see an exponent at all, there is really a 1. Then we go to our last one. 5 times negative 8 is a negative 40. There's no a for that to go with, so that a just still comes along, and 2 plus 2 is 4. So it kind of looks like a big, long, messy answer, but we cannot take that any further because none of those have exact matching exponents, and so we cannot continue or combine any like terms. And then for our last problem, we are going to be distributing a 10abc. Again, this is going to 3 terms, but again, we're just going to go one chunk at a time. So if we take this and we go here, 10 times 2 is 20. We have an a to the first times an a to the first, which will give us an a squared. A b times a b, which will give us a b squared. And then a c, right? The c doesn't have anything to go with, so it still just comes along and brings down to the final answer. Then we'll go to our second term. 10 times a positive 3 is a positive 30. A to the first times a to the first is a squared. There is no b, so that b to the first is just coming along. And c to the first times c to the first will give us a c squared. And then our last term, 10 times negative 4, will give us a negative 40. A times a will give us an a squared. B times b will give us a b squared. And then that c will just come along. Now, if we look at this problem, we do have one unique thing happening. Once we have this distributed, we do have 2 exact like terms happening, right? Right here and right here. These match in every way, shape, or form when we look at the letters, right? The a is an a squared. It is over here too. The b is a b squared. The c is a c. So when those match up perfectly, when those match up exactly, those are like terms that we can combine. Okay, we can't combine if it's kind of, sort of, or if this is an a squared and this is an a squared, but this is a b and this is a b squared, then it doesn't work. They have to be exactly. Okay, if they are exactly, then we are going to combine just like our rules of addition and subtraction, right? We add or subtract the coefficients in front. So 20 plus a negative 40 gives us a negative 20. And then we keep the label the same. Can't do anything with the 30 a squared b c squared, so it just still comes along and it's part of the final answer. And this would be where we are done.